Q3373. Below pressure height. Each 50 degrees Fahrenheit of positive superheat amounts to approximately A. 1% of gross lift. B. 2% of net lift. C. 2% of total lift. The correct answer is A. Positive superheat refers to the condition where the temperature inside the envelope of the airship exceeds the saturation temperature of the lifting gas. When this happens, the lift capability of the airship is affected. Each 50 degree F of positive superheat leads to a decrease in gross lift by approximately 1%. This means that for every 50 degree F increase in temperature above the saturation temperature, the airship will experience a reduction in its lifting capacity. 3374. When the airship is at pressure height and superheat increases, constant pressure must be maintained by valving A. Gas from the envelope. B. Air from the envelope. C. Gas from the ballonets. The correct answer is A. When the airship reaches pressure height and experiences an increase in superheat, it is essential to maintain constant pressure within the envelope. To achieve this, the excess gas needs to be released from the envelope. By valving gas from the envelope, the pressure can be controlled and prevented from exceeding the desired level. This helps in maintaining the structural integrity of the airship and ensures safe operation. 3375. How does the pilot know when pressure height has been reached? A. Liquid in the gas manometer will rise, and the liquid in the air manometer will fall below normal levels. B. Liquid in the gas and air manometers will fall below the normal level. C. Liquid in the gas manometer will fall, and the liquid in the air manometer will rise above normal levels. The correct answer is A. The pilot can determine when pressure height has been reached by observing the gas manometer and the air manometer. When pressure height is reached, the liquid in the gas manometer will rise, indicating that the pressure inside the envelope has increased. At the same time, the liquid in the air manometer will fall below normal levels due to the decreased pressure of the surrounding air. These changes in the manometer readings provide visual indications to the pilot that the airship has reached pressure height. 3376. The pressure height of an airship is the altitude at which A. The airship would be unable to gain more altitude. B. Gas pressure would reach 3 inches of water. C. The ballonets would be empty. The correct answer is C. The pressure height of an airship refers to the altitude at which the internal pressure of the envelope is equal to the ambient atmospheric pressure. At this altitude, the ballonets, which are compartments within the envelope that control the internal pressure, would be empty. This is because the gas inside the ballonets would have expanded to fill the entire volume of the envelope due to the decrease in external pressure with increasing altitude. 3377. The maximum altitude that a rigid airship can reach under a given atmospheric condition and then return safely to the surface is determined by A. The disposable load. B. Ballonet capacity. C. Pressure altitude. The correct answer is C. The maximum altitude that a rigid airship can reach and safely return to the surface under a given atmospheric condition is determined by the pressure altitude. Pressure altitude is the altitude above a standard reference point, typically sea level, where the atmospheric pressure corresponds to a specific value. It helps in determining the operational limits of the airship and ensures that it can ascend to a certain height and then safely descend back to the surface without compromising its structural integrity.